All right, so we are doing 1.5 right now. This is quadratic equations. Let's put this here. And my glasses, good. All right, so quadratic equations. We are, as you've seen on the list there, what we're going to cover. We are solving quadratic equations. And what we're really doing here is taking a quadratic which has this form, either a parabola opening upward or a parabola opening downward. These are the shapes for quadratics, as opposed to the lines that we were talking about in previous sections. So what we're trying to do now when we solve these quadratics, we're gonna have a general form of a quadratic equation that's going to look like this, where A, B, and C are constants, and X is the variable, X and Y, right? And we're looking at what we talked about in earlier sections on this Cartesian coordinate system. We're looking at a parabola. We're going to set Y equal to 0 in this section always, and that's what we're going to solve for. We're going to let Y equal 0. And so what we're doing when we solve this for Y, realize Y equals 0 are all the points along the x-axis. Right? Every point along the x-axis has a Y value of 0. So when we solve this equation and set the Y to 0, we're getting the x values where it crosses the x-axis. Right? We're looking for this point and this point. So sometimes we're going to get a situation that looks like this. Other times we'll get a situation that looks like this, where we're getting two actual solutions, two real as opposed to complex number solutions. So in this case, we're getting, I'll just leave one because we don't want to have two parabolas on one system. In this case, we get two real solutions, right, here and here, and we set the function equal to 0, the equation, we call it until we study functions. When we solve this equation for Y equals 0, we're getting the points where it crosses the x-axis. Now sometimes we're going to have this case where only the very top of the parabola touches the x-axis, or just the very bottom. Or something like that. Now, put arrows over here to show that it goes down and out to infinity. In this case, we're getting one real solution. Okay, just that point. We call that bottom point or top point a vertex of the parabola. So if just the vertex is the only point touching the x-axis, either opening upward or opening downward, we're only going to get one real solution when we solve this equation. And the third option is if the parabola opens up above the x-axis, so there's no x-intercepts, or it opens below the x-axis, going downward, and there's no x-intercept. So here we're going to get two imaginary solutions when we try to solve this equation. We try to solve this for a parabola that doesn't have any x-intercepts, either this one or this one. We're going to get imaginary solutions, solutions that involve I, what we talked about in section 1.4, I believe it was. All right, so we're going to have the four different ways of solving these equations. Go back and look at the four different ways of solving the equations, please. In 1.5, we're going to go through each one of those four methods of solving a quadratic equation. Okay. So I have some examples here. We'll start with the zero factor property and look at, I'm going to take problems out of your book, so this is a reason to make sure you have the book. If you don't have the book, you're going to be lost watching these lessons, so be sure you have a book to look at. All right, so we're going to look at number 4 on page 160. Number 4 on page 160. This is an example of a quadratic equation. All right, so the first thing we want to do is put it into this form. Okay, we want to have it in this form in order to use this zero factor property. So the zero factor property, the logic of what we're using here is ZFP for zero factor property. What the zero factor property says is if we have at least two factors being multiplied together equaling 0, and this extends to 3 or 4, however many, but we'll just use 2 for simplicity's sake. If we have 2 or more factors multiplied to get 0, well, that means that at least one of those has to be equal to 0. Either A equals 0, B equals 0, or both equal 0. Okay, that's the idea that we're using to solve these equations. So what we're going to do is first put this into this form. So we want 0 on one side and everything else on the other. Now, personally, I like to keep a positive number in front of the x squared term. Doesn't really matter what side you put it on, but I think it's a good practice to keep the positive number in front of the x squared term, the highest exponent. So we'll move everything to the left-hand side of the equation and put the 0 on the right-hand side. So we're going to add 11x to both sides, and we're going to add 10 to both sides. So we get x squared plus 11x plus 10, and then we're left with 0 on the right-hand side. All right, so now we want to create this situation. All right, so now this takes into account our prerequisite knowledge of factoring. Right? So if you don't remember how to factor a trinomial like this, you have to go back to chapter P and read that section about factoring and practice factoring. It's very important in this class. It comes up again and again and again and again throughout the year. So we want to use our methods of factoring to try to get this to be the product of two factors equaling 0, which is the if statement of the zero factor property. So we remember our trial and error method of factoring. The first product of the first terms here has to equal x squared, so we don't have any choice there. If there's a number in front of the x squared, we have more choices, more possibilities, but if it's just 1x squared, your choices for the first terms are always just going to be x and x. And remember here and here, we want numbers here and here that are factors of 10, such that the product of these factors equals 10, but the sum of the outside terms and the inside term, the sum of those products has to equal the middle term of 11x. So we think of factors of 10, 5 and 2, you can't get an 11 out of, but 10 and 1 you can. So you use 10 and 1. You got to be careful of the signs. These are all positive. We need the sum of this product and this product to be 11, so we're going to put a plus on both of those factors. Now we have the if statement of the zero factor property. We have one factor times the second factor equaling 0. So now we can go to the conclusion and say, when this factor equals 0, we get one solution. So we solve that pretty simple linear equation. We get negative 10. And then we solve this equation for 0, and we get another answer. So in this case, we get two possible answers. Both of them will work. And you can always check these answers. I'll leave that for you to do as practice. If you plug this negative 10 back into this equation, you should get a true statement. If you plug negative 1 into that equation, you should also get a true statement. So that's what you want to circle, label your answers is always a good habit to get into. All right, so that's the zero factor property. So the square root property is our second method of solving these types of equations, these quadratics. And a quadratic, by definition, is going to have the highest exponent in the equation is going to be a 2. Okay, so whenever the highest exponent is a 2, that's going to be a quadratic equation. So if we look at number 20 on page 160 for the square root property, So the square root property, your clue to use the square root property is going to be when there is no term with an x in it. Here we had the term with an x squared, and look at this part here. We had a term with an x squared, a term with an x, and a constant. When you don't have a term with an x and just an x squared, that's when you're going to use the square root property. And the square root property says, if I have something squared equaling a value, then I can take the square root of both sides. And remember to take plus and minus the square root of one side. You don't have to take plus and minus of both sides. Just take it of one side and you take care of the plus and minus. And this is only going to work when you don't have an x term. Right? You can't use this property over here because that x term is going to get in the way. But here, we can, again, we want to set up this if statement. Just like over here, we set up this if statement. To get to the conclusion, we want to set up this if statement. So we want to isolate the x squared. Right? So first we're going to manipulate this equation until all that's left on the left-hand side is x squared. So we'll add 7 to both sides first to get rid of the negative 7. So negative 15 plus 7 is negative 8. We still got that 2 in front of the x squared, so we want to divide both sides by 2. So we get x squared equals negative 4. Now you start to see that we're not going to get a real answer here, but that's okay. Remember we said we got those 3 cases. We can accept imaginary or complex number answers. So we know now we're going to take, so now we have the if statement that we wanted, right? So now we can go to this part and say x equals plus and minus the square root of negative 4. Now we dealt with how to deal, we learned how to deal with these square roots of negative values in section 1.4, I believe it was, complex numbers. So remember we said square root of negative 4 can be written as the product of the square root of 1 times the square root of 4. This becomes the I imaginary value. This is 2, so we get 2i for the square root of negative 4. So this is plus and minus 2i. And remember in section 1.4, we said many times we want to express our answer in the standard form of a complex number. So just to be completely correct, we have no real part of this number, so we can say 0 plus and minus 2i. All right, so remember this is the case where we have a parabola opening upward. I don't know exactly, it's not positioned exactly, but it's above the x-axis and it never crosses the x-axis. That's why we're getting imaginary values for our solutions. All right, so that is the square root property. All right, moving on to quadratic formula. Let's look at number 66.